Good morning, everyone. Welcome to science class for today. It is Wednesday, May 13th. And today in science class, we are going to define and give you some data on global warming. We're going to describe the effects that global warming is currently having and some of the more significant effects it could have in the future. And all I need for you to do for homework today is to submit a picture of the notes that you take from this video lecture. Okay, so how do humans affect the carbon cycle? Last time we were together, we described and diagrammed the carbon cycle. In other words, how these carbon-based compounds cycle through all those reservoirs or sinks and the natural processes that allow them to be able to do that. Up until recently, this cycle was completely natural. It kind of regulated itself until humans came around. Humans have interfered with this cycle pretty significantly over the last 200 years. And as you know, that is from the removal of fossil fuels and the combustion of them to do things that we want for energy purposes, for heating purposes, etc. And in doing so, we're taking fossil fuels that took millions, hundreds of millions of years to form and get stored deep in the earth, and we are blowing them up into the atmosphere in a blink of an eye in less than 200 years. Okay, this process normally would take millions of years to get back into the atmosphere. But to me, it's hard to think that when you're interfering this significantly with a natural system, there isn't going to be some sort of significant repercussion. Okay, so this is how humans are currently impacting the carbon cycle. Now, the greenhouse effect is being amplified really by our burning of fossil fuels, by the way that we're interfering with the carbon cycle. The greenhouse effect you guys should know, but I'll do a quick review. Our atmosphere, this atmosphere is not to scale, it would be much, much thinner if it were, contains certain gases that interact with sunlight in a unique way, or radiation, I should say. Now, when solar energy or radiation strikes the Earth, it can do one of three things. The first thing, it could get absorbed. So it could get absorbed and heat up that land or heat up that ocean that it strikes. Number two, it could simply get reflected back into space. Or number three, that radiation could bounce around in the atmosphere, being trapped by those so-called greenhouse gases. Now, that is what the greenhouse effect is. It's the idea that these special gases, these greenhouse gases in our atmosphere, interact with that solar radiation and trap it and do not allow that heat energy to go back out into space. So is that a good or a bad thing? Well, it's a great thing. Without the greenhouse effect, our Earth would be a frozen, lifeless place. The greenhouse effect is what allows our planet to be habitable, okay? It would be extremely cold here if our atmosphere didn't hold in a significant portion of that heat instead of just bouncing it right back out to space. Now, the greenhouse effect is called that because it's the same phenomena that we find in an actual greenhouse. As sunlight streams through the clear glass, it's going to heat up things in here, okay? The flowers, the concrete on the floor, that heat's going to kind of radiate back out, but it's going to go hit the glass basically and ping, 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 ping. It can't get back out. So that heat is just going to be trapped and just kind of start circulating in here. That's going to cause this to get warmer and warmer over time as more and more sunlight shines through. Now, this is no different than the Earth, okay? Instead of the glass trapping the heat, we have gas trapping the heat. So basically, the gases in our atmosphere act much like this glass and keep that heat inside, not letting it out. If you recall when we talked about the EM spectrum, we watched a video on infrared, which again, thermal energy is giving off infrared radiation. So this scientist, she actually held up a piece of clear glass, which visible light passes straight through. But then when we looked at that image through an infrared camera, we could see infrared energy cannot pass through glass. So this is exactly what we're talking about in the greenhouse. And the gases that we're talking about, those greenhouse gases, do the same exact thing. Okay, let's talk about the greenhouse gases. I do want you to know what they are, and I've listed them in order of abundance. The first one is actually water vapor, so evaporated H2O. It's very prevalent in the atmosphere, as you know. It's why we have precipitation and things like that. But it does act as a greenhouse gas. Now, the problem is, as global temperature slowly rises, the rate of evaporation is going to rise. And that's going to then evaporate more water, which is then going to make it warmer. et cetera, et cetera. We're going to find a lot of these unfortunate runaway effects, as we like to call them when we're talking about global warming. The second most prevalent is CO2. We know CO2 is increasing and has been for some time, and the main source of that is the burning of fossil fuels. Deforestation is also causing CO2 to increase because we don't have all these wonderful trees pulling that CO2 out of the atmosphere to undergo photosynthesis if we're cutting them all down. The third most prevalent greenhouse gas is methane, CH4. The number one source of methane is livestock emissions. What do we mean by that? Cow burps, okay? It sounds kind of silly, but there are many, many cattle on Earth right now to feed the world's want for meat and beef. Okay, many people like eating meat. We have about 1.5 billion cattle on the globe right now. Each of them is producing between 40 and 100 gallons of methane per day. And it has to do with the way they digest things. Cows kind of chew things repeatedly, things come back up, and that process and digestion releases methane. The problem with methane is it is about 25 times more potent as a greenhouse gas than CO2. So methane, even though it's number 3, it can have a huge impact if you're pumping a lot of it up there. The fourth most prevalent greenhouse gas is ozone. And we're talking about ground level ozone, which is really precipitated by air pollution. Okay, let's take quick notes on greenhouse gas and the greenhouse effect. So please write the greenhouse effect. It's the trapping of heat by gases in the Earth's atmosphere. It's essential for our planet to be habitable. So it's a good thing. If it gets too strong, not a good thing. The greenhouse gases I want you to know, and let's also list them in order of abundance: water vapor, carbon dioxide, CO2, methane, which is CH4, ozone, which is O3, nitrous oxide, N2O. And again, that's also going to be from fossil fuel burning. Also causes acid rain, as you guys know, because our nitrogen oxides and our sulfur oxides. And lastly, CFCs are actually greenhouse gases. The good news is we've greatly decreased the amount of CFCs in the atmosphere. Okay, I'm going to pause there. I'm going to start the next video with global warming.